So at the beginning of your talk, concerning the arrows of time, you pointed out a quantum arrow that was over and above classical arrows. So you start with classical.
Not necessarily. I said it is. I don't assume it is another arrow, but this is an action we can talk about. Non-unitary collapse.
Okay.
This is what I
So
mean.
if there was an arrow that applied to quantum scale things, wouldn't we expect to find empirically time asymmetric phenomena on those scales? Like, I'm not talking about a model, I'm talking about the phenomena themselves.
I think this is the reason most of us think we can't time reverse quantum mechanics, not quantum mechanics, the one branch quantum mechanics. What we see in the lab in a strong measurement experiment cannot be reversed. This is asymmetric.
Okay, so what are the quantum phenomena that are asymmetric? Can you give me an example of
I'm talking about the regular decoherence. When the information, quantum information leaks to the environment, we tend to believe it cannot be tried. I'm not saying maybe this is the first kind of time.
By coupling to a large system,
Sure.
though, you're now bringing in perhaps the first.
This is the underlying mechanism I'm talking about. Sure. This is what I try to show using the two-time decoherence. This is how I treat measurements and collapses. There is no a real collapse. There is coupling to a very large system. There must be more questions unless I make it very badly.
Do you have an opinion about something which I was under the impression that you still don't have a final opinion? Does something cross the event horizon of the black hole? You know, there are people who say that actually there's, I wouldn't say an open question, but something about which people are not clear. Something falls into a black hole and then when it comes to the horizon, I don't see it actually crossing it. It becomes only more pale, the radiation becomes, the wavelength approaches infinity and so on. So there are some people who say that nothing actually crosses the event horizon. Are you suggesting something to that effect?
No, I'm not suggesting it. I talk about in falling observers and in falling matter.
So they do cross.
In my opinion, if you ask amps, then probably there is some limitations on this crossing, but in my opinion, the event horizon is not of significance. An infalling observer would see no drum in the language of amps.
Other questions?
I mean, I have a question. I guess I can phrase it as a question. Do you think that there's something wrong with non-unitary evolution? Because I think there are many indications from quantum gravity that it just cannot be unitary, and they have nothing to do with black holes. So, I mean, you presented everything, which many people do, as a paradox in need of some sort of resolution, but do you have any rationale why that must be the case? Why the evolution should be unitary? Why the process of formation and evaporation should be described by a unitary S matrix?
There are several possible answers for this question, I think. First of all, I want to talk about reversibility, which is the result of unitary, but not.
So I didn't hear what you said. Stability?
Reversibility.
Reversibility.
Yeah, of the same reversibility we know from Newtonian mechanics, and we know from the equations of quantum mechanics. I suspected, I think as Hawking suspected back on the 70s, that would be the part of black holes until he found out this information paradox. And it is called a paradox because it is non-unitary. And I think that also in quantum gravity, the idea CFT correspondence lets us always talk about unitary processes in conformal field theory. So I don't really understand why there should not be unitarity in nature.
Well,
But,
we could have a long
the third
discussion.
level is finally a matter of taste. You saw the slide on the scar, and I think this is the approach many people have, that they prefer to see nature as unitary. But
well, I mean, yeah, it would be a long discussion, but even if you believe, I mean, I believe that in a fundamental discreteness underlying space-time, and that makes unitary evolution extremely unnatural, especially.
This might be a really long conversation, because we think that what you observe as non-unitary field theory on the lattice is really negative or imaginary weak values.
Okay,
Imaginary
I don't
weak
understand.
values within a unitary process. We can have, we can. But I just wanted to say that even if you believe in unitarity, it's not necessary to believe that as far as the external region is concerned, that one sees unitary evolution. I mean, some of the early suggestions were that baby universes form and carry away part of the information. So I don't see how you can. I mean, another thing is ADS, CFT. All these things are very tangential, right? There's no proof whatsoever that ADSC is really true in the regime that it would have to be true in order to prove unitarity. But again, even if you believe it, one doesn't know what it describes. Does it describe just the external region? Does it describe some combination? The whole of existence? If it describes the whole of space-time, that may have the baby universes, and they may be entangled with the external region. So it seems to me all the arguments, when you look in detail, they are weak. They have many, many loopholes. And it's much simpler, actually, to accept non-unitarity. But I agree, it's just an argument. It's not an argument that we can settle. But I just want to say I don't think it's quite objective to describe the situation as if everything must be unitary for the external region. And then we have to modify whatever physics or... I think you're right, but currently I think it can be shown that unitarity is not violated.
Can be shown?
Let's guess we can show, using this way, that unitarity is not violated. I don't have reason to think otherwise, because I didn't see a quantum gravity full theory, a full theory of quantum gravity.
Right.
So I tend to believe that the theory now described. But
Right, it was differently. But did you say it can be shown that we have unitary evolution?
I say let's
assume
that we can show. I mean, we have several assumptions, and I think it is meaningful to take those assumptions and to see what they lead to.
Sure.
Even if we will find out one day that they were wrong. Right now, I don't think these assumptions are wrong.
Okay. I had a completely different question if there's time. I don't know. I just didn't, you said in the very first part of your talk, this is related I guess, but in the first part of your talk, you seemed to say that you can reverse irreversible processes. And I just somehow didn't understand what you were saying. Is there a short way that you can summarize what the point was?
Yeah, this was an important point. We need first to define what can be reversed and what we mean when we say to reverse. The first kind of time error, the thermodynamic, can be reversed, and we agree on it, right? The other, apparently different, but not necessarily, and probably it is not necessarily different, that I think we can reverse the collapse when it comes to macroscopic objects.
So,
To readings of macroscopic measurement devices. And the third reversibility I talked about is in the extreme case of curved space, when again we think that information is lost, but we can retrieve it using the final state.
okay, so the second one was the one I didn't understand.
Okay.
So is it different from, I mean, someone could say, yes, well, if you take the whole environment into account, you have reversible evolution. Most people would probably agree with that, except those who believe in a fundamental non-unitarity.
Right,
But if we ignore that fundamental non-unitarity, then everyone would probably agree. But is that what you're saying, a special case of that? Or is it something distinct?
No, this is clearly distinct, because what I tried to emphasize that people believing in the many worlds interpretation have no problem of reversing physical processes. This is essentially what you mean. If I take the large, very large system, I can reverse time. But if I have only a small open system, I think in several cases I can reverse it too.
I think we have to continue this conversation later and for the next talk, so thank you, speaker again.